హలో 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 వీళ్ళకి ఎక్కువ అవుతుంది కదా. దిస్ ఇస్ నాట్ అవును ఆగిపోయింది.
ఇది ఎందుకు పెట్టారు ఎందుకు అసలు దీనిలో వీడియో క్యాప్చర్ ఎక్కడ వచ్చింది వచ్చింది
హలో హలో
అదంతే కెమెరా
ఇంకా జూమ్ చేయండి. జూమ్.
మనం పద్ధతులు ఆడతాం అది వద్దంటారు అది వేరే పద్ధతే కావాలి. వీడియో కూడా క్లారిటీ వచ్చేసా జీసీసీలో జూమ్ చేయాలి క్యామ్ని అలా చేయాలంటారు. క్యామ్ని జూమ్ చేయాలి ఆ రిమోట్
ఏంటమ్మా ఇది? ఇదో కొన్ని వాటర్ వాటర్. Ma, kindly draw this diagram. For the construction it is required. For the construction it is required. You have to draw. So here rotor is having rotor slots, starter is having starter slots. So whenever we are connecting, Amma listen, I am explaining the working or principle. Same principle as the transformer. Whenever we are connecting three-phase supply to the starter, okay, in the starter an EMF is established. Okay, whenever we are connecting the supply, okay, what happens? Because of the current flowing in the winding of the starter, an EMF will be established. Before that a flux will be established, alternating flux will be established. So that is dpi by dt. So this alternating flux is capable of induce an EMF. Okay, so that is nothing but flux is establishing in nothing but because of it is a three-phase connection. because it is a three-phase connection. Three terminals are there. R by B, red, yellow, black, or red, yellow, blue. Okay, so whenever these three-phase terminals are connected to the supply, a three-phase current is flowing through the starter conductors, okay, and rotating magnetic field established in the stator. Rotating magnetic field is established in the stator. So here rotating magnetic field established at the starter conductors here. So this rotating magnetic field is linked with the rotor conductors. This is the rotor. Rotating magnetic field is linked with the rotor conductors. Okay, so whenever flux is linking with the rotor conductors, an EMF will be established in the rotor. Simple. d pi by dt, whenever flux is changing with respect to time, an EMF will induce in the conductor. Okay, so now see, I repeat. So this stator connected to the three-phase terminal, three-phase R by B, not a single, okay, terminal, it is R by B, three-phase terminal. Whenever this three-phase terminal is connected to the supply, a current of I is flowing in the winding. Which winding? Stator winding. So stator winding current will flow. So because of these conductors are placed in the stator slots, a flux will be established in the stator. So this flux is capable, that flux is nothing but, it is nothing but, because of it is a three-phase, you can say rotating magnetic field. So a rotating magnetic field established in the stator. Rotating magnetic field established in the stator. This rotating magnetic field is available here in the stator. Rotating magnetic field is available in the stator. So this rotating magnetic field linked with the rotor conductors. Rotor conductors also available. Okay, rotor conductors. So the flux, the rotating magnetic field is linking with the rotor conductors, and EMF will establish in the rotor conductors. Okay, an EMF is induced in the stator conductors and EMF induced in the rotor conductors. Okay, so EMF is available in the rotor conductors. Voltage is established. A voltage is available in the rotor now. Okay, voltage is available in the rotor. So this voltage, okay, so because of these conductors, what happened to these conductors? These conductors are short circuited. Listen, induction motor rotor conductors are short circuited. For induction motor, rotor conductors are short circuited. So short circuit means they are closed in nature. So because of the circuit is closed, a current of I is flowing. Okay, I is flowing. So whenever an EMF induced in this rotor conductors, this EMF, okay, flux is available. This flux is capable of linking the rotor conductors, rotor current. So these rotor conductors now establish a rotor magnetic field. Rotor magnetic field. So starter magnetic field, rotor magnetic field. So two magnetic fields are available because of the stator, because of the rotor, two magnetic fields are available. So these fields, okay, this is a rotating magnetic field, and because of the stator, other magnetic field because of the rotor, they are interact each other such that the rotor of the induction motor start rotating. Because of interaction between the two fields, one is stator field, second one is rotor field. Okay, the two fields interact with each other, they will start rotate, rotor will start rotating. Okay, so it is the principle. What is the principle? Whenever we are connecting three-phase supply to the terminals AC supply, okay, an EMF is induced in the rotor conductors. Okay, so a current of I is flowing in the rotor conductors. This current is capable of inducing rotating magnetic field. So this rotating magnetic field, it interact with the rotor conductors. Rotor conductors. So then an EMF is induced in the rotor conductors. E1, E2. Same as the transformer, E1 is there, E2 is there. And this secondary rotor conductors are short circuited, that is enclosed in nature. These rotor conductors also establish an EMF. Okay, rotating rotor EMF and a starter EMF. Both are interlinking with each other, then rotor starts rotating. Rotor of the induction motor starts rotating. Okay, this is the principle and working of the induction motor. Okay, now, so here rotating magnetic field establishing. Rotating magnetic field is establishing. So rotating magnetic field means how much speed of that rotating magnetic field? Rotating magnetic field speed is given by, rotating magnetic field speed is given by Ns is equal to 120 F by P. Okay, rotating magnetic field. The speed of the rotating magnetic field, the field which is established in the stator of the induction motor, having the speed of Ns. What is the meaning of Ns? Synchronous speed. Synchronous speed. Rotating magnetic field speed is synchronous speed. Ns is equal to 120 F by P. What is the F? What is F? F is nothing but frequency of the supply. What is P? P is nothing but number of poles. Number of poles available in this stator and rotor. Okay, so poles. Then that is the speed of the rotating magnetic field. What is the speed of the motor? Speed of the motor is given by N. N is nothing but speed of the rotor. So rotor speed is not equal to synchronous speed always. In the induction motor, Ns is not equal to N. What is Ns? Synchronous speed. What is synchronous speed? Rotating magnetic field. Field is revolving. Okay, that speed. Field speed. Okay, stator will not revolve. Rotating magnetic field speed. What is N? N is nothing but rotor is revolving. Rotor is revolving, that speed. Okay, so always in the induction motor, synchronous speed is not equal to the speed of the rotor. If Ns is equal to N, that means synchronous speed, rotating magnetic speed, field speed and rotor speed, if it is equal, then the induction motors will stop. Okay, that's why a new parameter is known as slip. So slip is equal to slip is nothing but slip is equal to, the formula is Ns minus N by Ns into 100. Okay, that is slip percentage. Slip percentage is given by ns minus n by ns. Okay, two speeds are different. Two speeds are different. Okay, what are the two speeds? One is rotor speed, that is n, other one is synchronous speed. These two different speeds, okay, that is ns. Two speeds are different. N, this is n, this is synchronous speed. They are not equal. If synchronous speed, that is rotating magnetic field speed, is equal to the rotor speed, then induction motor start revolving. It will not rotate. It is at a standstill. Okay, so this condition is known as standstill condition. Standstill condition. What is the standstill condition? Whenever rotating magnetic field speed is equal to the rotor speed, then the induction motor will not revolve. Okay, did you see for the ceiling fan? For the ceiling fan, we are switching on, but it will not rotate. It will give some buzzing sound. It will not rotate. What happens? Okay, and one more thing, these rotor slots are not equal to the stator slots. Rotor slots are not equal to the stator slots. Okay, that is also please keep in mind. So with respect to construction is concerned, so how many parts we are having? One is stator, other one is rotor. Stator consisting of stator slots, rotor consisting of rotor slots. So stator is made up of cast iron. It is mentioned, cast iron. Okay, and rotor is also made up of cast iron. We are inserting the winding in the stator as well as rotor. Two windings, one is stator winding, other one is rotor winding. So this winding is made up of copper. Okay, so this is about induction motor working and construction only. Okay, how many windings are available? Two windings are available. What are they? Stator winding, rotor winding. Which material we will use? Copper. What is the function of the stator winding? In order to establish, what happened? In order to establish induced EMF, we require starter winding. What is the function of the rotor winding? Here also E2 we require in order to induce an EMF in the secondary. Same principle, V1 I1, V2 I2. Okay, so in order to establish an EMF in the secondary, so we require rotor winding. So rotor winding of the induction motor gets short circuited. That means a closed path will be established in the rotor conductors. Okay, so this is about construction. Just you have to draw the circuit diagram. You have to explain about each part: stator slots, stator conductors; rotor slots, rotor conductors. That's all. 4, maybe 6 parts are available. What are the functions? What are the use? Which material you are using? That you have to explain. That is about induction motor. Okay, right. So everything is available in the. This is not required. Okay. This is not required. Actually, rotor. How many types of rotors we are having? This is not required actually. That is enough. So, but for your knowledge purpose, I am explaining. The rotor of the induction motor is divided as two types. One is called squirrel cage 3-phase induction motor. Other one is slip ring induction motor. So these are the two different type of induction rotor of induction motors. Okay, not required this one actually. Okay, no need to write this one. Okay, rotor types is not required. Kindly make a note. Why? Because it is in the notes. No need to study. But how many types we are having? Kindly write down. There are two type of, okay, rotors are available. One is squirrel cage induction motor. Second one is wound rotor types. Okay, that is nothing but here wound rotor 3-phase induction motor. Okay, so now so what are the applications of induction motor? What are the applications of induction motor? So induction motor is available in the submersible pump. Do you know submersible pump? In our house we are having one motor where the water will sucks and pour in the tank, submersible pump, induction motor. And for agriculture purpose we are using induction motor. Okay, in the fan, ceiling fan, induction motor. For table fan we are having induction motor. Okay, so what is the efficiency of induction motor? What is the efficiency of induction motor? Induction motor efficiency is nearly 60%. Okay. So this is about induction motor. Write down one problem, okay, with respect to induction motor. This, what are the formulas you are having? Induction motor. What are the formulas you are having? One is slip. That is equal to S is equal to Ns minus N by Ns. If you require slip percentage, Ns minus N by Ns into 100. Okay, one more thing is there. So because of the two magnetic fields available in the stator and rotor, so here also you are having two frequencies, rotor frequency and starter frequency. Okay, so always the starter frequency is nothing but F dash is equal to S into F, rotor frequency. Rotor frequency is equal to S into F. What is S? F slip. What is F? Frequency of the supply. Okay, so F dash is nothing but rotor frequency. So here in the transformer primary winding frequency is equal to secondary winding frequency, but in the induction motor primary winding frequency is not equal to the secondary winding. Why? Because F dash is equal to S into F. What is F? What is F? Applied voltage frequency. What is F dash? Rotor frequency. Rotor speed N, stator speed Ns. Okay, write down one problem. Write down one problem. If the synchronous speed of induction motor is, write down, the simple problem. It is a simple problem, two-line problem. If the synchronous speed of induction motor is 1500 rpm, if the synchronous speed of induction motor is 1500 rpm, and the rotor speed is 1400 rpm. and the rotor speed is 1400 rpm. Determine slip of the induction motor. Determine slip of the induction motor. So slip can be calculated by using the formula ns minus n by ns. So ns is given. What is ns? 1500. What is n? What is n? 1400. So 1500 minus 1400 by 1500. Okay. So here the question is ns given data. ns is given. ns is how much? Synchronous speed is 1500 rpm. Rotor speed is 1400 rpm. Okay, calculate slip. Slip is nothing but ns minus n by ns into 100. That is equal to 1500 rpm minus 1400 rpm by 1500 into 100. That will become slip percentage. How much? How much? Huh? 6.66 or 6 point something? 6.6. So slip is 6.6%. Okay. Calculate the next one. Calculate the synchronous speed. Calculate the synchronous speed of a two-pole induction motor with of a induction motor with 50 Hz frequency. With a 50 Hz frequency. So it is also a simple problem. Given data, calculate the synchronous speed. ns is equal to how much? For the two-pole 50 Hz frequency of induction motor. What is the formula? ns is equal to 120 f by p. How much? $300? 3,000. 3,000 rpm. 3,000 or 300? 3,000. So synchronous speed of alternator is given by 3,000. Okay. Right. You draw the any one diagram. Alternator, that is AC generator. Alternator, AC generator, not DC generator, AC generator. You draw the any one of the diagram. You can draw like this one, otherwise that one. Whichever is easy, you can draw. Otherwise, kindly try to practice this diagram, any one of the diagram. Okay. So alternator, what is meant by alternator? Alternator is nothing but AC generator. AC generator. Okay. So AC generator means, so what is the difference between DC generator and AC generator? Exactly opposite to DC generator will become, listen, with respect to construction is concerned, exactly opposite to DC generator is nothing but AC generator. Okay. Now you have to tell me what is meant by, what are the different parts you are having. Stator, DC generator, stator is nothing but field winding is available. Which winding is available? DC generator. For the DC generator, which winding is available? For the DC generator, stator and rotor. Stator consisting of pole, pole shoe and winding. DC generator, yes, but here exactly opposite I said. Rotor consisting of rotor conductors. Rotor consisting of rotor conductors. Okay. So kindly remember DC generator. Exactly opposite to DC generator is nothing but alternator. Exactly opposite. What is the meaning of opposite? Construction. Principle is same. No need to worry. Principle is same. Principle of alternator, that is nothing but AC generator, is same. It is works with the principle of Faraday's laws of electromagnetic induction. There is no other principle is there. Generator. So in the DC generator, okay, conductor is rotating. DC generator principle, can you remember DC generator principle? A conductor revolving in the magnetic field. Whenever a DC generator, whenever a conductor revolving or rotating in the magnetic field, an EMF is established in the conductor. Yes? So stationary is field. Stationary is field. Amma, kindly remember the DC generator. Exactly opposite. If you know DC generator means you have to exactly write down the opposite. Same principle, opposite. What is opposite actually? That I am explaining. So just now I am explaining DC generator. DC generator principle. Starting off, that means yesterday. Okay. Conductor placed in a magnetic field, Okay, a moving conductor placed in a magnetic field. Field is available north pole, south pole. Field is available, flux is flowing from north to south. Okay, so conductor is rotating. So a rotating conductor is placed in a magnetic field and EMF is established in this conductor. Okay, that is the principle. Here also same, but vice versa. Means opposite. Means here we are placing conductor constant, stationary. Here these are the conductors. These are the conductors. So here the color indicates that RYB. AC, it is AC. Alternator means AC generator. So AC generator means three phase supply. RYB. That's why the color indication red, yellow, blue. Three phase supply. So conductors are placed in a stator of the alternator. Stator of the alternator. That is three phase supply. It is a generator. Okay, generator means what is the input? You have to rotate. Here I am rotating. Okay, so in DC generator conductors are rotating. In DC generator conductors are rotating, but in AC generator field will rotate. Field. Okay, so here conductor I am placing at one place. It is not rotating. Now field is rotating. So conductor is around the field. So this is field. North pole, south pole, north pole, south pole. Okay, this whenever this field is revolving, what happened? Field is rotating now. Field is rotating. Okay, what happened whenever this field is rotating? What happened? These conductors cut by the flux. Conductors cut by the flux. So an EMF is induced in this stator. An EMF is induced in the stator. So the EMF induced in the stator is nothing but AC. So directly we are taking out of three phase supply RYB. Okay. So this is three phase supply RYB. So these are connected red. All reds are at here one terminal, all yellow one terminal, all blue one terminal. RYB. So these are the conductors now. These are conductors. Okay. Conductors are placed in the stator slots. So instead of general DC generator, in general DC generator means conductor is revolving in the magnetic field. Conductor is revolving in the magnetic field and EMF is established in the conductor. Exactly opposite. Now conductor is at stationary. Conductors are stationary. They are constant. They will not rotate. Field is revolving. Field is revolving. Okay. Now how can I make this field? How can I make north pole, south pole, north pole? How can I make? By wounding around the that iron piece, that poles. Okay, or pole shoe. Around that will wound the copper conductor. Then only it will act as a north pole, south pole, north pole, south pole. Okay, field is revolving. Then who will give the supply? Who will give the supply? Here it is. Field is rotating. Field is rotating, is not a constant. So now what we will do? We will connect a small DC motor here. Small DC motor here, shaft. See, that's why it is called here. These two are called, okay, slip rings. These first one and second one. So this is plus terminal, this is minus terminal. These two terminals are connected to a small DC motor. Why? Because this rotor battery you have to connect. Why? Because they have to act as the north pole, south pole. You have to connect battery to this. North pole, south pole, north pole, south pole. Okay, you have to connect battery to this. Okay, in order to connect this north pole, south pole, in order to establish north pole, south pole, we have to connect this terminal. These terminals are there, na? Write this. Okay, like this, like this, like this, like this. So this is connected to here positive terminal. This is connected to negative terminal. Starting terminal, end terminals for this. So these are brushes. These black are brushes. Okay. These black are brushes. So these are now can be called as slip rings in order to give the supply to the rotor conductors. Okay, in order to give the supply to the rotor conductors, we have to add a small DC motor. Why? Because we require field here, north pole, south pole, north pole field. Okay, so this is called one type of okay rotor. Here also same. Here also same rotor. Rotor is having rotor conductors. Starter is having starter conductors. Okay. Same. These are the two different type of rotors. Okay. One is called salient type rotor. No need to discuss about that, but just you note down any one. Okay. One is called salient type, salient, not silent, salient type rotor. Other one is cylindrical type, cylindrical type rotor, cylindrical type rotor. Okay, cylindrical type rotor. So this is called cylindrical type. Here also these conductors wound around this, it will establish north. Here anti-clockwise direction south, clockwise direction north, anti-clockwise direction south. These two terminals connected to the one terminal is connected here, other terminal is connected here. So that will plus and minus symbol. Why we require north pole, south pole. That's why one of the terminal is connected to one brush, other terminal is connected to other brush. These brushes are on the slip rings. Slip rings. Slip rings means two different materials, copper type materials, plus and minus, where a small DC motor is connected. Okay, right. This is about construction. Simply principle construction. Only what are the with respect to construction is concerned, construction of alternator. Okay, here also there are two parts. Here also main two parts. One is called stator, other one is called rotor. One is called outermost, one is called stator. In the stator we are having the slots, stator slots. In the slots, okay, three-phase winding is connected. In the slots, three-phase winding is connected. Okay. And what about the rotor? Over. Stator only having the slots. Stator is having only stator slots. In the stator slots, three-phase winding is connected. So stator is the material we are using, stator as cast iron. And the hello, hello, hello. అరే రే ఇక్కడ ఇయ్యండి.
ఇది తాగేది పెట్టినా
So rotor. So rotor. Second one is rotor. So rotor consisting of rotor slots. Yes? No. Rotor consisting of poles, that is north pole, south pole, north pole, south pole. Rotor consisting of poles, these are pole, north pole, south pole, north pole, south pole. Here also north pole, south pole, north pole, south pole. Both are same. So with respect to construction is concerned, rotor of the alternator consisting of poles for the both, whether it is a salient pole or cylindrical pole, it has slip rings. Why we require slip rings? What is the function of slip rings? So slip rings are the terminals, okay, which will give the supply to the poles from the one small DC motor. Okay, we'll connect a small DC motor here. This DC motor terminals are connected to the slip rings. Thereby these brushes will collect the current which will give supply to the poles. Okay, so rotor of the induction alter motor consisting of, one is winding which is wounded around the poles. Second one is poles. What is the function of poles? Poles will deliver the flux. To the conductors. Where are the conductors? Conductors are stationary now. Exactly opposite. In DC generator, poles are stationary. In the AC generator, poles are moving, will rotate. Opposite. In DC generator, conductor is rotating in the DC generator. Okay. In the AC generator, field is rotating. Okay. Right. This is about construction of alternator. What is the application of alternator? AC generator. Where will use AC generator? So AC generator is used in generating stations. AC generator application is used in generating stations, and generally I am saying whenever power is off, what will use? We will use generator, that is called AC generator. Okay, so our college has the generator. That generator is nothing but alternator. That generator is called alternator. Okay, so for all companies, industries, okay, wherever we require power, whenever general power is off, we'll use this alternate power as the alternator power. Okay, right. This is about alternator construction and a principle. Okay, so with this total machines are over. DC generator, DC motor, transformer, induction motor, alternator. Only working construction, EMF equation of the generator, EMF equation of the transformer. Okay, you take 5 minutes break, but don't go away anybody. Okay, you go only two persons. You take 5 minutes of time and return back. We'll start electrical measurements now. So second part is electrical measurements. We'll start that one. Okay.
హలో 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 మేడం స్టార్ట్ రా.
Hello. 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 So this is the Amma listen. Depending upon the time permits, I will complete this one. Okay. So listen. Kindly listen. So here instruments. So generally, what is meant by instruments? Generally here we are discussing with the electrical instruments. So electrical instrument means which will measure the quantities. Which will measure the quantities. Okay. So before that, now instruments. So generally instruments are classified as two types. One is primary instruments, second one is secondary instruments. Primary instruments, second one is secondary instruments. So the other name of primary instrument is absolute instruments. Absolute instruments. Okay. Second one is secondary instruments. So there are two type of instruments. One is primary instruments, second one is secondary instruments. So what is meant by this absolute instrument or primary instruments? Okay. So you have to measure the quantity. So what are the different quantities we'll measure? We'll measure the weight. We'll measure the weight of the any quantity. We'll measure the liquid, how much liters. Liquids can be measured in the liters. Okay, gas. Okay, so weight we will measure, liquid will measure, and gas will measure. Okay, so that is with respect to, for example, weight means 1 kg. You will go and buy the 1 kg rice, 1 kg sugar. So what is meant by 1 kg? Here sugar is unlimited, but you require a limited 1 kg sugar. So 1 kg. So you are comparing with respect to, okay, not measured quantity. Comparing with respect to you want 1 kg sugar. So sugar is having more, but you require only 1 kg. So you are comparing. So with unknown to known. 1 kg, 1 liter. Okay, like this. So this is called absolute instruments. So generally absolute instruments means technically we cannot use this absolute instruments. Technically we will not use. Okay. So we will use secondary instruments. So secondary instruments means we will measure the voltage, we will measure the speed, we will measure the power. Okay, we will measure the current, we will measure the energy. Okay, so these are all parameters we will measure. So these all parameters, voltage, current, power, electrical quantities, power, energy, speed. So these all comes under, so direct measurements. Direct measurements. We are not comparing with the other thing. 1 voltage is comparing with unknown. No unknown is there. Directly we are measuring. Okay. So that is called secondary instruments. So these secondary instruments further classifying as three type instruments. Secondary instruments are further classified as, first one, indicating instruments. Indicating instruments means, for example, I think you have seen the voltmeter, you have seen the ammeter, whether it is in the circuit directly, which will give the indication. 3 volts are there. How much voltage? 3 volts, 10 volts. Okay. So that is nothing but indicating of voltage, indicating of current, okay, indicating of power. So one is the secondary instruments can be classified as indicating instruments. Second one is integrating instruments. Integration, you know, integration, mathematics integration, differentiation integration. What is meant by integration? So integration means we are measuring the quantity with respect to time. With respect to time. Okay. Example is energy meter. In our house we are having energy meter. For 1 month we will measure and they will give the bill, electrical bill. This power this energy you are using, power into time. With respect to 30 days, you are used this much of power, you have to pay the bill of this much. So that energy meter is nothing but integrating instruments. So the parameter is measured with respect to a period of time. With respect to period of time is nothing but integrating instruments. Integrating instruments. Okay. Third one, recording instruments. Recording instrument. What is the meaning of recording instruments? Okay, it is an instrument which will record with respect to time. Okay, with respect to time. So now 4 o'clock, what is the voltage, what is the current, what is the power? 4:30, what is the voltage, what is the current, what is the power? 5 o'clock, what is the voltage, what is the current, what is the power? 6 o'clock, like this, every 1 hour, every 5 minutes, every 10 minutes, that is decided by the respective usage. Or every day, today morning voltage how much, 230, current is how much, 5 amps, power is how much. So recording, and recording whenever we require. So I will see back, okay, yesterday, okay, in 1999 morning, January 1st, okay, in Hyderabad, what is the voltage, current, what is the voltage? So that is nothing but recording instrument. Recording means that can be stored and we can call back. Okay, so these are the 3 different type of instruments. What are the 3 different type of secondary instruments? First one is indicating. Indicating means directly. For example, now I require to measure what is the voltage. Just now in the circuit, okay, it will show 230 voltage. What is the current? It shows 9 amps. What is the power? It shows something. That is nothing but indicating at instant of time. Now I require. That is indicating. Integrating means from January 1st to January 30. Total calculating. Integrating means adding. So we are adding the energy, power into time, power into 30 days. Integrating, adding. At the end of 30 days, what is the power consumption? Okay, they will give the bill. Integrating means adding. First day, second day, third day, up to 30 days. Example is energy meter. So energy meter is integrating instruments. Voltmeter, submeter generally we are using in any lab. That is indicating instruments. Recording instruments. Recording instruments means which will measure and which will record and store over a period of time. Whenever I require to see back, for example, yesterday evening 5 o'clock, what is the voltage, what is the current, what is the power, used by the KIET. January 1st evening 5 o'clock, okay, what is the voltage, used by the KIET, what is the current, okay, that is nothing but recording type. Okay, so first one is primary, secondary. Primary is not technical, it is non-technical, like 1 kg, 1 liter, like that. Technical is this one, secondary instruments. Okay, and here absolute instrument means galvanometer. I think in inter, okay, galvanometer, you know, galvanometer is nothing but which will comparing the left side, which will comparing the right side. Okay, we are taking ratio. Current through the galvanometer should be 0. Okay, comparison. 1 kg means 1 kg. we are comparing with unknown value, that is nothing but primary instrument. So it is direct. Okay, these are the three indicating instruments: indicating, integrating, recording. Okay, so here recording instruments generally we will use in the power stations. Power is generating, morning power, how much power is generated. Okay, 1 hour, 9 o'clock, how much power is generating, 10 o'clock, how much power is generating. I think you have seen the paper. Generally you are seeing paper. Generally in the paper one news called in the summer the utilization of power is more. Yes, that article is there na. How they know? How they know? How about in last year summer the utilization of power is less, but this year the utilization of power by the particular town is high. How they are saying? They are comparing with respect to old last year summer data with respect to today data. Yes, means every parameter is recording. So that's why recording instruments. Okay, integrating means energy meter. First day, second day, third day, fourth day, total adding. This is the power consumption. You have to pay the money. Okay, that is integrating. Okay, right. Now, with respect to instruments is concerned, so with respect to syllabus is concerned, you are having PMMC instrument and moving iron instruments. What is mean by PMMC? Permanent magnet moving coil. Permanent magnet. You are using permanent magnet. Moving coil. Coil will be rotates. It will move one place to other place. Okay, it will move. Okay, so do you see the voltmeter, ammeter in the lab or any place? It will show. Okay, what is the voltage? Okay, so so that is nothing but permanent magnet moving coil instruments. Other one is moving iron. Okay, so this PMMC is there na, permanent magnet moving coil instruments are used to measure the DC quantities. Permanent magnet moving coil, okay, instruments are used to measure the DC voltage, DC current, DC power, DC energy, like that. Whereas moving iron is used for both DC as well as AC. You can use for AC voltage, you can use for DC voltage. Okay, right. Now see, in order to know about the before going to discuss about the permanent magnet moving coil, so here we require torque. We require to know about torque. Can you define torque? What is the difference between speed and torque? Speed, revolutions per minute. How many revolutions are, this is how many revolutions are making with respect to minute. What is meant by torque? What is meant by torque? Is there any formula for torque? Torque formula? Force into torque is equal to force into what? Force into displacement. So torque is equal to force into displacement. What is the meaning of displacement? What is the meaning of displacement? What is the meaning of displacement? What? Shortest route. Huh? Displacement shortest route. Okay. So velocity is having direction. Okay. So force into displacement is nothing but torque, that is physics definition. What is meant by torque? What is meant by torque? So torque is nothing but silent pettamma. So here, so torque is nothing but, I can say, with respect to a fixed point, rotational force is nothing but torque. With respect to an axis, how much forcibly any circle, any moving with respect to one axis, force with respect to an axis, how much force is attained by the, for example, you say wheel, any circular one wheel, okay, at a particular place, what is the difference between speed and torque? Speed is nothing but, okay, from one place to other place you can go. Speed of your bike. With respect to time, what is the speed? Number of revolutions per minute with respect to time. Whereas the torque means it at one place only, what is the force occurring? Rotational force, you can say rotational force. That is nothing but torque. So, in order to know the concept about PMMC and PMI, that is moving iron instruments, here we required three torques. What are the three torques? One is called deflecting torque. I will tell, okay. One is called deflecting torque. Second one is called controlling torque. Third one is called damping torque. Okay. One is called deflecting torque. Second one is controlling torque. Third one is called damping torque. Okay. So, do you see any analog meters? In any place? Analog meter, do you see? No, you have not seen analog meters. Voltmeter, ammeter, energy meter. Energy meter means there will not be any indication. In energy meter there is no indication. Okay. Analog meters are there. Seen? Do you seen? Voltage 230 volts, like that you have seen? You seen? Okay. So I will show now. Okay. Now, in order to function, in order to work, any instruments, whether it is a PMMC or MI, permanent magnet moving coil or moving iron instruments, we require three torques. One is called deflecting torque, controlling torque, damping torque. Okay. So, in order to understand these three torques, okay, let us consider this diagram. Kindly understand this diagram. See, these are the magnets.